Okay, test, raz, dva. Okay, it's working. So, good morning everyone and welcome to Kubernetes Community Days Czech and Slovak 2026 here in Prague. We are happy to have you here. This is already our 5th edition and it's amazing to see this community is growing every year. Today and tomorrow this place is full of cloud native people, ideas, story and hopefully also good coffee. So first question, how many of you are at KCD for the first time? Raise your hand. Yeah, quite a lot. So what is KCD? Kubernetes Community Days are some regional events organized by local communities but connected to global cloud native computing ecosystem. This event is supported by Cloud Native Computing Foundation, the home of Kubernetes and also a lot of nice cloud native project. And the idea is simple. Bring people together, share some real life experience, learn from each other and help community growth. So this event is hosted by two organizations or maybe two communities, Cloud Native Prague and Cloud Native Bratislava. These communities do not exist only for these two conference days. They live during the year through meetups, talks, discussion and networking. So if you want to speak, help or just meet some nice people from Cloud Native world, please join us at some next meetups. My small challenge to you, do not only listen to the talks, try to talk to someone new, maybe ask some questions, visit sponsor booths, and the most important, take at least one idea from this conference and try it at home, in your team, in your platform. This is how conference become useful, not only inspirational. This event is organized by volunteers, people who have normal jobs, families, incident, deadline, and still decide to spend many evenings preparing these events. So please give them some applause. Thank you. Without them, there is no KCD. If you are lost, confused, or looking for something, for some room, Wi-Fi, coffee, or meaning of life, please ask organizer. You can recognize us by this purple t-shirt. And this event would not be possible without our sponsors. Thanks for your support, the community, not only with money, but also with people, knowledge, and a presence here at the event. So please visit their booths, talk to them, ask questions, and maybe take some stickers. Yeah, stickers are the real currency of this cloud native world. Now I would like to invite our platinum sponsor to say a few words. So maybe let's start with TSP Data, David.
Hello. Dobré ráno. Good morning, everybody. Thank you to having you here. So I see some familiar faces, so that's nice. So I'm David Ledvinka from TSP Data. I'm there responsible for sales. We are here as a platinum partner, and I would like to introduce you what we bring to this conference. TSP Data, it's a Red Hat premium partner. We are focusing on DevOps, GitOps, and everything what's connected to Red Hat. Also, we are doing observability or monitoring based on Dynatrace or Zabbix. And what we will do at this conference. So today, from 11:25 in this room, my colleague Martin Štefany will talk about llm-d. Really nice presentation, so don't miss it. And tomorrow from 1 o'clock in room 120, Miroslav Kolář and Robert Tekal from our company will talk about immutable edge at scale. So it's a 3 hours workshop, and who will join the workshop, it's possible to win a Raspberry Pi 5. So I think that it's a nice present. And also we have a stand here in that exhibition area. And today we got a lottery for Lego. So it's 3 o'clock, so just stop there, scan our QR code, fill the form, and you can win. Just one information, winners are only in person, so we are not sending it by post. So thank you.
Thank you, David. And we have here And our next platinum sponsor is Cloudera. Zdeněk.
Hey. Oh, so many similar faces which I know. So I'm Zdeněk. I hope that you know me, at least if you are based in Prague, because I'm also doing the Cloud Native Prague meetups. But yeah, I already joined the Cloudera, so today I will be speaking about what we are doing there. So I hope that you know Cloudera, but to be honest, I know that you not. So the Cloudera is just a company which are using, it's a big data warehouse which provides some solution for it. And also these days, if you are not using AI for the big data, so there's no way, right? So we are also implementing our own AI solution for the big data. But what is important and why we are here is that our solutions are based on the CNCF landscape. We use most of the CNCF tools for our platform, where our tools are running. I mean, like Kubernetes, you know, Flags and stuff like that. And we also have many of contributors to the CNCF project. So feel free to join our booth and discuss us, because we are building right now the Tech Hub in the Prague. It started right now. So if you are interested, just talk with us. That's it. Thanks.
Thank you, Zdeněk. And do we have here someone from F5? Okay, so please visit them in their booths. So, and of course, big thanks also to our gold sponsored Red Hat, Prusa Research, and Ondrej Šika. Please applause for them. Next information, all talks are recorded and will be published on our YouTube channel. And we also have here a photographer at the event. So if you want some nice photo for LinkedIn or just for your memory, just ping him or use our photo wall. We will also have lightning talks today at 5 p.m. But according to my last information, all slots are already occupied. Today at 6 p.m. we will take a group photo. Please come and join us. Last year the photo looks great. You can see it, but this year we want even more faces, more smiles, more Kubernetes energy. So please join us. And today, after the program, we continue with after party. It starts at 6:30 at restaurant na Kotlářce, but capacity is limited. So please ask for some after party badge. It looks like this. It is available at registration, or some of our sponsors have it. I think talks are great, but many of the best conversations happen after this, so it can be nice to see you also there. Yeah. Yes, and tomorrow we will finish with raffle. We have some nice prize from our sponsors, for example, 3D printers, some voucher for certification. So I strongly recommend staying until the end. Yes, and this is all from me for now. Thank you for being here and enjoy the talks, meet some new friends, ask questions, have fun. One more time, welcome. All right. 5 minutes or 10 minutes.
Do you want to say something first? Okay. Sounds good.
Do you have something with sound?
No, no.
So I can see this screen, so it's correct.
Yeah, yes, it's working.
So you stay here?
I think I might grab one.
You have clicker.
I have a clicker, yes.
1, 2, 3. Cool. Okay, since the room is almost full packed already, I think we can go ahead and leave Kasper for his keynote. And he will be talking about rethinking observability as a platform product. And he frankly has a lot to cover, so I'll just hand him the mic.
Perfect. Thank you so much. Yeah, so it seems like I got like an additional 10 minutes, so let's see how I can fill that. So thank you so much for being here, and thank you to the organizers for inviting me. It's a pleasure to be the one to open this event. So just let's give the organizers a big round of applause for setting this up. Yeah, so my name is Kasper. I currently work as, if this is working, it does, as a Director of Product Marketing and Developer Relations at Dash0. I'm a former KubeCon, Cloud Native Con co-chair. My last tenure was in London last year, which is, if you haven't been to a KubeCon, it's an awesome event. Definitely encourage everyone to go there if possible. Also, last year wrote this book around OpenTelemetry for dummies. It's like an introduction book into the space of OpenTelemetry and observability. So there will be a QR code later if you're interested in getting a copy. Also, a CNCF ambassador, I've been doing this since 2018. So I've been doing similar things as this event, organized community events in Denmark, also KCD in Denmark. Now it's Cloud Native Denmark. So if you are around the area or want to submit a talk to Cloud Native Denmark, feel free to do so. It's in November. Yeah, I think that's enough about me. Today I want to talk a little bit about Kubernetes initially, because we'll come to the observability part a little bit later. Because I think Kubernetes changed a lot of things over the last 10 years, 11 years now. It sort of gave us these raw primitives and incredible powers, and we have things like pods and services and deployments and all of the things that you know from this ecosystem, right? But it sort of failed to give us a product experience, for developers especially. And I was back in 2019 at KubeCon, Cloud Native Con in San Diego, and Brian Lyles gave this awesome keynote where he mentioned this thing that Kubernetes is a platform for building platforms. And he also sort of extended that Kubernetes is a vehicle that takes us to our destination. And in that keynote, he also pointed out that Kubernetes sort of, back then at least, sort of missed its Rails moment, because Rails, if you're familiar with Ruby on Rails, it sort of gives the developer a paved path, like opinionated defaults. It's just easy to get started. Whereas Kubernetes, on the other hand, is quite complex, especially from a developer perspective. It has these raw powers, but it's sort of missing that product experience. So let's have a look at sort of the developer's cognitive load over time. So I tried to plot this, and it's sort of inspired by a good friend of mine, Daniel Bryant. His original talk is linked here as well. But this is sort of the cognitive load seen from the developer perspective over the last 25, 26 years. So back in the early days where we had the monolithic applications, right, it was fairly easy. We sort of had some clear boundaries that development was doing development and infrastructure was running infrastructure. So from that perspective, the cognitive load was quite easy to deal with. Then we started to move into a more distributed area with service-oriented architectures, and now we had sort of a network boundary that as a developer you needed to sort of take care of and deal with and build your services around. And then there was this moment where everything sort of reset. I'm not sure if anyone or if everyone in here remembers this, but back then Heroku came around with git push Heroku master, and from a development perspective, that this was super easy. It's just git push Heroku master, and then everything was in production, and everything was taken care of for you. And then this happened, right? Kubernetes, microservices. We started to build more and more and more, and the cognitive load of the developer just increased and exploded, because now they had to deal with Docker containers and Kubernetes manifests and pods and services, ingress rules and whatnot. I was back at this point, I was working at a bank, and we did the same thing. We just pushed Kubernetes YAML, Docker files, and everything onto the developer, because back then there was this quote around shifting left, shifting security left, shifting observability left. Everything was shifting things onto the developer, and the cognitive load of the developers were just exploding. And I think platform engineering kind of emerged as this sort of savior to developers in this space, because that is really where the sort of the development cognitive load sort of like flattened a little bit again, because now we had a platform team that came in and tried to absorb a lot of the complexity, but still we had the raw power of Kubernetes underneath. So if we simplify this, so initially developers were just interacting directly with Kubernetes, and it kind of wasn't a good experience, right? Because developers probably has other things to do than figuring out how to run a kube control command or kubectl or whatever you call it. So we put this thing in between that we call a platform, right? So this is really the thing that is put in to absorb all of this complexity and still have the raw powers of Kubernetes underneath. So that makes developers more happy. And if we put this in, there's a lot of like talk in the ecosystem around this, and I think this was back from around 2018, 2019, when Evan Butcher sort of defined what he saw as a digital platform. And a digital platform is a foundation of self-service APIs, tools, services, knowledge, and support arranged as a compelling product. And I think the compelling part is really the important bit in this quote. And this has since then just like this idea of creating internal products exposed to our development team has just grown and grown and grown. So this is from the team topologies, where they define what a platform team is. And if you look at this definition, it's provide a compelling internal product to accelerate delivery by streamlined teams. So a compelling product again. So we need to build a product and expose that internally to our developers. And now this was from last year's KubeCon in Atlanta. Centasso published this O'Reilly report around platform as a product. And I think that this has been a topic in the ecosystem for the last couple of years, that now we really need to treat our platforms as products. So to have basically, we treat them as evolving products as we would do if this was an external thing. So we do like get feedback, we create experiences around how it is to run on this platform. So the missing abstraction is sort of the full picture here is that you as a platform team on a Kubernetes platform, you absorb complexity by building different products that you expose to your developers. And I think observability should be part of one of these platform products so that you can create a really nice curated experience for your developers so that they just get everything out of the box. So let's take a look at observability and how it sort of looks today, because I think many of the same mistakes are happening in this space as in the early days of Kubernetes. Because observability promised quite a lot of things, that you would be able to do faster root cause analysis, you would be able to understand what is going on in your systems, and with that understanding you would be able to lower MTTR, and that of course also like implies that you're reducing guesswork. But I think the reality is probably more around where do I start? There's so many different tools here, and which tool is the right tool, and how many tools do we need? And why is this metric suddenly spiking from this CNCF project that I just put into my platform? I have no idea what it does, but I get the insights and now it's spiking, so what is going on? And then this thing that I call human correlation, where you have an ID in one tab, in one system, in Prometheus, whatever, then you need to go figure out in your logging system or your tracing system, and you do a lot of correlation across basically browser tabs. And that is what I would call either manual or human correlation. So you become sort of the correlation engine in this. And if you sort of visually try to like display this again, we have a lot of different browser tabs, right? We have our logs in one browser tabs, we have metrics in another, we have traces in a third. We also have maybe something around the real user experience from the mobile application or the website, whatever we have. But we also have maybe profiling when things go wrong and we want to like inspect what is actually going on in the systems. And as everybody in here probably know, that naming is hard, right? So we also, in all of these different tabs or systems, we might also just have different ways of defining what maybe a level is in this case, or what a service name is. Maybe it's app in one, and maybe it's service underscore name in the second, and something else in the third one. So that correlation just is becoming really, really hard, and especially when we have maybe hundreds of thousands microservices. So finding that needle in the haystack when something goes wrong just becomes even harder. So the current reality is that we have a lot of fragmentation in this space. We have in each of those browser tabs you just saw, there might be a complex query language or filtering mechanism, or however you sort of figure out how to find that data that you're needing. And in many cases, we also have vendor login, because this space has been built around, especially if you buy a product from a vendor from like 5 to 6 years ago, or 5 to 10 years ago, you would have like an agent that is vendor specific. You might have some frameworks you need to add into your code base, or some libraries, and then you are really, really locking yourself into that particular vendor. And yeah, this is the metadata inconsistency, or the naming inconsistency between the different tabs is also a big problem in this fragmentation space. And because of all of this complexity in this space, it often leads to either only instrumenting 1 or 2 of these signals, and that, of course, is not like the way you want to do this. Because each of these signals provide like a view into your system, like a different view into a system. So you're missing out on sort of this lack of unified insights across all of these different ways of looking at your system. But this isn't necessarily a tooling problem. I think there's been great like examples of great tools out there in each of those pillars. But I think the problem right now is that those pillars only represent this partial view of your system. So we need to figure out how we are correlating across all of these, in this case, 3 pillars. But I don't think the 3 pillars of observability is really how we should frame this. Because as you saw in the browser tab example, there was like 5, and there's probably more coming. So let's like stop talking about the 3 pillars of observability and call them signals instead, and recognize that there is more than just the 3 of these. And also, we don't have a metrics problem or tracing problem or logging problem. We have a systems problem. There's something wrong with our system that we need to understand and figure out. So looking back at the early days of Kubernetes, we had all of these tools, and we see the same thing in the observability space. So this is, you're probably familiar with this, the CNCF landscape, but this is only like zoomed into the observability side of things. And just in that category, there are so many different tools to choose from. Luckily, there's one up there that is sort of the foundation for many of these that I'm going to talk a little bit about today, which is OpenTelemetry. So many of these tools either integrate or build on or in some way interact with OpenTelemetry. So that is hopefully the sort of the answer to a lot of the problems, but we'll come back to that. So we have a lot of powerful primitives, but we don't have like this default experience of getting it easy up and running and getting the insights that we need. We need to do a lot of things ourselves. But luckily, as I mentioned, there's this shift happening right now towards OpenTelemetry, and what that shift really provides is a shift towards correlation, so that you are able to actually find related information because you have like a standard for how you're defining and naming things, which also allows you to maybe when some kind of metric is spiking, you are able to correlate that to the actual span or the trace, and then from there on, jump into the actual logs and figure out what is actually going on. So it really allows you to reconstruct the chain of events. And that is really nice when you're woken up 3 a.m. in the morning and something is wrong, instead of you having to find an ID in somewhere and put it into a third system and trying to understand what is going on. So this is really a shift towards OpenTelemetry as that standard, as the foundation for how you're basically observing your systems. How many of you are familiar with OpenTelemetry, just by show of hands? Great. How many are actually running OpenTelemetry? A little bit fewer. Okay, good to see there's some running it. So OpenTelemetry is an open source project designed to basically provide a way to standardize tools and APIs for generating, collecting, and exporting telemetry to wherever you prefer. That's really up to you. So it started as a merger between OpenCensus and OpenTracing 6 years ago, something like that. And it's become the de facto standard for distributed tracing, metrics, logs, and now also profiling, which is in alpha state right now, and also browser instrumentation. So you can basically do all the 5 signals that I was talking about before. And the main goals of this project is really to unify telemetry, be vendor neutral, and be cross-platform. And cross-platform in this sense means that you are able to basically use whatever language or whatever you have out there and use OpenTelemetry for that, because there's SDKs in all different languages. You can just take them down and start instrumenting your applications. And actually last week, OpenTelemetry just graduated, so now it's become a CNCF graduated project, which finally happened. It took a long time. So that is awesome to see. That also means that hopefully more and more will start adopting this. In a nutshell, what it is that it's a data model. It's API specifications. It comes with this thing called semantic conventions, which is really where we are defining what things are and what values they can take. So this naming problem thing is sort of a solved problem now, because now we all, as a community, agree on an HTTP code. It's http.response.status.code, which is really nice. It's a good foundation to build on top of. It also has this these different libraries and implementations for all of these different languages that you might have. And it also comes with utilities such as a collector that allows you to collect all the telemetry and send them again to whatever backend you want. And then it also has an operator and other tools, and I'll show you the operator in a second. But it's not proprietary. It's not an all-in-one observability solution. So you still need a data storage. You still need some kind of dashboarding solution. You still need some query language on top of all of this. And it's not feature complete yet. There's a lot of stuff going on in this community. That I think the OpenTelemetry GitHub organization itself has around 100 different projects at the moment. So there is just a lot of stuff that happens in this space. And if we look at sort of the velocity report from the CNCF report that I think was published a couple of months ago, it's still one of the top projects in the ecosystem. Especially, it actually is above Kubernetes on PRs plus issues. So there's just a lot of momentum going on right now. And that's also visible in the survey that came out in January from last year, that actually 49% of the respondents for that survey are saying they're running OpenTelemetry in production. An additional 26 is evaluating. So that's really awesome to see. So the signals, I already mentioned those 5 signals, whereas metrics, logs, and tracing is stable, and profiles and real user monitoring is more sort of on an experimental alpha state. But the superpower of the project is really this correlation piece, that it really allows you to correlate these different signals so that you can actually jump between them, and they can provide you this partial view into your system and putting it together so that you actually get system understanding out of it. And this is how you would simplify a setup. You need to instrument your application somehow, and there's different ways you can instrument your applications. Either you do this manually, just writing instrumentation, you import the SDK, you start writing and setting everything up. But there's also auto instrumentation that you can, for Java, for example, you'll download a Java agent, you will put that in the Java tool options with the agent flag, and then you can basically run that and it will do all the instrumentation for you. Similar for many other languages. But you can also do this using a Kubernetes operator that I will show you in a second. You can also basically observe all your infrastructures. For Kubernetes alone, there's 5 different receivers that you can configure in the collector to receive either from the kubelet. You can get all the metrics from there. You can have it pick up Kubernetes events. You can get all the kube API stuff out there. So you can basically instrument everything. And this is not only for Kubernetes. This is for basically all the projects that you're most likely using. You can do that. And then you can put this into the collector. There's a processing pipeline. So you can do a lot of interesting things there. You can redact certain things. If you have sensitive data, you can just redact that. You can do filtering, you can add things, you can basically do whatever you want. It's a kind of a data pipeline, and then you can export this to wherever you feel like you want to export it. Whether you decide to go with a database for each signal, or you find some vendor out there that has a unified backend. So basically what OpenTelemetry is doing is that it's standardizing how telemetry is collected. And hopefully it will be sort of the last observability agent you will ever install, because once you are on this standard, you can just point your exporter to whichever vendor or whichever tool you want, and that is way more easier than ripping out agents and frameworks and stuff like that in your code bases. So I would definitely recommend everyone to start looking at that if you're not. Now let's switch gears a little bit, because telemetry without context is just data. We really need context around things, right? Because if you're just looking at a graph like this, any guesses what this could be? Just shout them out if you have a guess. What? A heart signal. Yeah, that's a good one. It could also be response codes. It could be approval ratings by, I don't know, some president in the US. I don't know. But actually, this is sort of the number of legs versus how cute they are. So the context, right, really matters. And what do I want to say by this is that we talk about system context in different ways that in our systems, right? Because we have all the way down to the infrastructure layer. We have which data center is this running in, what region in the cloud, what availability zone. It could also be which cluster is this on sort of the more platform level side of things, which namespace, which deployment was this, was it a cron job, whatever, what was it? It could also be the container layer, sort of on the compute layer, what process. But then we come to sort of on top of all this, then we have the architecture, right? The thing also has a name. Who owns that name is sort of the last step. Is all of this matters in terms of the context that this thing is running in and that you're producing your telemetry in. And the cool thing about semantic conventions that I talked about a little bit earlier is that there's really conventions for most of these layers, except the top one, but I'll come back to that. So all of the basically the scores up here is basically links to the semantic conventions where you can see how a cloud is basically being generalized as the cloud.platform equals AWS or whatever it might be. Same for Kubernetes, same for OSs, system processes, whatever. I think there's even like hardware stuff and batteries, and so there's semantic conventions for a lot of different things. But the organization part is kind of missing, which is a little bit of a shame. But I know there's work going on in the ecosystem to define basically service.owner or something like that. But there's also tools that allows you to do that yourself. Like OpenTelemetry Weaver is a project under the OpenTelemetry organization that basically allows you to define your own semantic conventions. So you could also build your own semantic conventions around department or whatever you find relevant for your organization, which is quite nice. So all of this context, of course, needs to be provided out of the platform. And you as a platform engineer sort of have this dual responsibility, and you, of course, need to observe the platform. So you need all of this information when you're like observing your own stuff. But you also need to enable your developers to get this insight, to understand where they're running their applications. And if something goes wrong on a node or whatever, you need to understand and be able to correlate that this is coming from a problem either on my side or on the application side. And how can you then do this? Well, I think we need to talk a little bit about sort of paving the path to observability and providing observability as a platform product. And what I mean by that is really that the development experience from this is that you just deploy your service as a developer and you get everything out of the box. You don't have to deal with instrumentation or like setting up all of these things. You, of course, add your own business context for whatever you are like building in that service, that is your responsibility, but all the other stuff underneath, like the HTTP requests, all of this is basically something that should be provided out of the platform. But then you might be asking, how do I actually do that? And I think operators is really the sort of the delivery mechanism for some of this, and especially from the collection and instrumentation part. So in the OpenTelemetry project, there's this thing called the OpenTelemetry operator, and what it allows you to do is that it allows you to do auto instrumentation basically via custom resources. So there's a custom resource called instrumentation that you can apply in your cluster. You define some configs where data is being sent, where's my collector running, and then you add an annotation to a pod, and whenever that pod is being deployed into Kubernetes, it will auto instrument that application for you. I will show you, I think I have time to do a demo, so maybe I will just do that in a second. But let me just finish this. So OpenTelemetry is really like how telemetry is produced and collected. You still kind of need to, as a platform engineer, figure out what kind of mix of vendors and open source tools do you want to use for sort of the backend side of this. And some of the things that you should like take into consideration when you're doing this is how should my developers actually interact with this? How should they ask questions about my systems? How, also in this world we're living in today, how do agents understand and interact with the data that I'm producing out of this? Because I think that is definitely sort of the next step in all of this, is that we will have agents that are becoming like a stakeholder of the platform to some extent as well. So you need to think about that when you're choosing your tools. Because you probably know this, that if you put garbage in an LLM, you get garbage out, right? LLMs need structure, they need something to reason about. And that thing is really what OpenTelemetry is also providing from an observability perspective is this specification and the semantic conventions that we now agree on, that this thing is called this, and it means this, and it can take these values. And if your telemetry is conforming to that, you will basically have like rainbows and unicorns and stuff like that, because now the LLM can actually start reasoning about what this thing is and start correlating the different signals and come up with understanding of and providing basically incident resolutions and stuff like that. Come on. So it basically allows you to start asking questions about your system. Of course, this depends on the tool that you're using and displaying your data in. But you can basically ask questions around any issues with my system today, or why is service something failing, and help me to understand this trace. I can see there's 1,500 spans, and I don't want to like go through them all, so like surface the most important things for me. But I think this is just the beginning. So this is like sort of the reactive part that we are in right now. This will become proactive. You'll see agents running and doing this automatically and figure this out themselves. Maybe even do, you know, PRs back into your code base if it has that access and that knowledge. So it's going to be an interesting sort of time for the next, I don't know, months probably. So without the conventions, the semantic conventions, and the correlation sort of fails. And without the correlation, AI just guesses. But with this structure and with the context that you're providing, AI now starts to reason about the data and about the problems that are going on. So why observability as a platform product? Well, it will reduce the cognitive load that I talked about in the beginning. It will just be that experience for developers. They're just building the features, creating whatever value they are like hired to do, not run infrastructure. And they will get all of this out of the box. They'll get the understanding, they'll get the signals. And then, yeah, it will be sort of the foundation for AI-driven workflows as well. So developers can actually focus on delivering business value with observability as a built-in kind of a safety net. So I think I'll skip to the other mic. And hopefully this is on. Perfect. So I want to just quickly show you what I talked about before. So this is a local cluster that I have running on my machine. It has basically a to-do application. So it has a front end. You can see the front end part up here. It has a to-do backend, which is basically just an API, and it talks to a database. And that sends notifications through RabbitMQ to a notification service. Pretty simple to-do applications. There's no reason for basically the async part other than I wanted to try it out to see how it works. And then I have in the cluster, I have, like, as you can see, we have some agent collectors. So I'm running the OpenTelemetry collector as two different deployments, one as a daemon set and one as a deployment. The daemon set runs on every machine, so it can pick up logs, it can talk to the kubelet, it gets all the node information. Whereas the central one is more around talking to the Kubernetes API, figuring out how many replicas, deployments, stuff like that, getting the events from the API, which is nice. So that's sort of the application. If we then just quickly show you, so this is the front end. I can zoom a little bit. So I can just add a to-do in here, and you can see that it receives the notification. That's perfect, awesome, it works. If we then move into the observability side of things, so this is Jaeger. I'm only showing you this using open source tools. I don't want to be vendor pushy or anything like that, so this is just sort of the tracing part of it. But in most cases, you probably want something that is more across like a unified solution. But this is just to show you sort of the tracing part of it. So if we do this, we say create to do. 942, I think that must be the one. So you can see now I have all of this is basically just being automated out of the box. So you get a lot of insights. You can see there's what do we have? We have some repositories as an insert into a database. It communicates, it publishes a message to the other service that is then consuming all of it. That's awesome, that's great. But what I want to show you is basically if I start from like a new service. So my platform team in this case are using Backstage to create abstractions and just make it easy for me as a developer. So you probably have something similar to build some kind of abstraction for your developers. And I cheated a little bit because this is the actual service. So this is this is the scaffolder in Backstage. And what you would use in the real life is probably like, this is the best practices for how I run a Node service or Go service or how I configure whatever it might be. I already pre-filled all of this. So this is nice. We'll just create the service. Then my platform team in this case provided me some nice steps that I'll just copy and move into the terminal. So you can see now I created this validation service. So this service is basically a service that the goal is that the to-do service just asks the validation service whether or not that this to-do is allowed or not. And if it is, it says 200 OK, otherwise it gets a 400 for some reason. I can just quickly show you the code. Because the thing is that, and what I really want to show you is that you don't have to manually instrument or do anything in the code. So this is the code. It's a really poorly written Node application. But there's nothing specific in here around metrics or traces or spans or anything like that. It's just the logic. So if we run the command, so this is basically my CI/CD. This is not how we would do it in production. This is only for demo purposes. So it's building the application, and it's going to push it into the cluster, hopefully, in a second, using kind load. Again, you will have probably some CI/CD system. You will have Argo or something running in your clusters to apply all of this. Great. And part is initializing. That's great. While it does that, let me show you what the platform team in this case then also added, because if we take, let me find it, the deployment specification, which was also created through this scaffolding process. So the platform team in this case added this annotation, which tells basically the OpenTelemetry operator that this application wants to be instrumented automatically. And I mean, this is a Node.js one, so I need to inject Node.js instrumentation into this application. That's nice. So that's basically how the operator is instrumenting all of this. So let's go back and just do a request. So I think there was 3 words that was bad. So bad is a word that is not allowed. Oh, I forgot one thing. So I forgot to actually, I have in the to-do service, the team owning that service is basically, they have a feature flag that I need to enable for it to actually call. So let me just quickly do that. And we can see if it's actually working. It's running, that's perfect. Let's try again. And now it fails. So now it's part of this, basically this like request chain. And if we go and look at the actual telemetry now, we should hopefully see that all of this is now part of basically the traces that you saw before. And this, you can see now actually the validation service is here. So it's already part of the distributed trace that we have from before. And in this case, it fails. We can create, let me just create one that goes through as well. So by OTel swag or something. Oh, sorry. Let's find the trace. And there we go. So it's all automatically instrumented. It's part of the trace. You can see that the to-do service now calls the validation service, and that is also instrumented with some things. It has information about, all kinds of different information that conforms to the semantics, cluster ID, blah, blah, blah. All of this is part, all the context is now here and can be used for basically anything, which is pretty nice. So that is one way you can basically build this into a platform and make it easy for your developers to get this out of the box. So from the development perspective in this case, they didn't have to do anything. They just had to write the logic, apply it into the cluster, and they get the defaults out of the box. So I definitely encourage you to start building some of this into your platform now, because as you probably know, AI is moving pretty fast these days, right? And if you don't have this foundation, basically this knowledge and this agreement and contract about your telemetry, utilizing all the AI to get the insights into your data, into your systems, is kind of hard, because garbage in, garbage out, right? And you will probably fall behind. You will see your competitors are just automatically resolving all of this, and you're spending more and more time on actually understanding what is going on. So that was all I had for you. If you are interested in getting started with OpenTelemetry, feel free to scan this QR code. It's to the OpenTelemetry for Dummies book. It's a good way to get started. It just has the basics. It takes like an hour and a half to read. Also, just a quick shout out to Merge Forward, which is a part of the CNCF. It's for basically trying to create communities for everyone. So if you're interested, just check out the QR code there. It's a great course. I'm an ambassador for them as well, so check it out. And with that, thank you so much for having me and for listening to this talk.
Okay. Thank you, Kasper, for the talk. It was great. We have nothing at Slido, so maybe they will leave that for the panel discussion in the evening. And we have one small problem. The workshop room is empty, so go fill it out, please. It starts in 5 minutes, and it's Cloud Native PG. Everyone loves that. Okay, the next talk will start in 5 minutes. Okay. So let's take our seats. And for the next talk, I would like to welcome David Pech, and he will talk about how they built an AI incident responder, again, which I'm kind of interested how it goes. And you may be mistaken about this dual presentation, and he will just do it single-handedly. As always, you can scan the QR code for Slido, and you can post your questions, and they will be answered in the end. So the stage is yours.
Thank you. So hello, and I definitely welcome you for some interesting session on the AI agents that's gonna, of course, replace us. So my name is David, and I'm still being employed and still not being overrun by agents. But I'm so glad that I see so many people that might be unemployed in a few years because of the phenomena. So just maybe quick look back at the KubeCon, not just the previous one, but many of those. Basically, every other booth is telling you something like, hey, this is an agent that will take away your work and do something for you. More, closer. Pardon. Okay, so technical difficulties, sorry about those. So the pitch is very simple, right? You plug in the agent to your infrastructure, of course, to your production. When there is an incoming alert, the agent will wake up. It won't wake you up. It will do some magical fix, and then your production is safe and sound, and of course, you can uninterruptedly sleep for the rest of the night. But the reality probably is not like this. So first of all, I think that we won't be hearing about many of those companies with these offers like next year or the year after it. We are really in an explosion of these tools. Everybody would like to have a bite of those. Definitely some of those won't survive. The vendors, I think, currently are not very, let's say, skilled with some read-write experience. So they can showcase the most perfectly, but are you really willing to let them into your production, like with some safeguards, etc.? So first thing that there is, I think that we should be much more realistic what we can expect from the agent. Not that it will solve all problems, but let's say that it would just help us on the investigation part and lower the time after we wake up. How much time do we need to pick up what's really going on and maybe pinpoint the exact problem. So here maybe there is some much more realistic pitch what it can help you with. It is still very valuable, but you are not letting write the agent to your production. So basically this is again the demo and the problems it silently assumes. So first of all, the agent knows the same things you do, right? It knows where to look inside of your GitOps repositories, which file to change, how they are layered, and sometimes they are taken by some other tools. So they are not all of those are very primitive to understand. For example, they have of course right credentials. We trust them to do their job, right, in the full extent of what we want them to do. And in this example, for example, we have something like out-of-memory kill, which is very easy to understand. And the agent, in my case, try to enhance the memory 25% up. Does it make sense? 25%, I mean? Should it look maybe and investigate from the metrics how the application can behave? Maybe I am running some Java application and it has some different definition what the application within the container can take. Is it reasonable? Etc., etc., etc. So it's definitely not easy. So let's take a few steps back and let's really think how you should approach SRE, incident agents, anything in this direction. This is our approach. So we said, okay, we need to buy a product, of course. How do we do it? This is what we know, right? We are engineers. But who is it for? And honestly, we don't know. I mean, obviously, we would like the ops people to get some help. But DevOps people as well? Should we also help the developers and in shifting left? Maybe. And what it should do? Again, it's funny, but we don't know. Because we've seen some wonderful examples what it can do, but is it viable in our infrastructure to do the merge request for increased memory, or should we let it just investigate? We really don't we don't know what we want. We are not buying a car and we know how to run a car, what it can do, right? For the SRE agent is very different. So technicals, I will basically skip those. We have wipe coded some Python, let's say, basement on Claude Agent, SDK. Some of us are Entropic fans, let's say. We've tapped it to our Slack to talk with it through Slack. And we also bundled a lot of repositories. The most important part is the last one, that we have some workflow. Because the thing is that what did typically some companies, some vendors are approaching you, hey, we have a wonderful tool that will do this. You buy the tool, and now you have a context problem. Because what the tool really should do, what your company specifically would like it to do, where you do allow it to do anything. So just to explain, our product, or like our tool technically, could sell bread over Slack, with a different context. Why not? And it can be very easily replaced. This is the major takeaway. So what we have is not that important in comparison to this context and integrations and like the way how we treat it. I have a lot of screenshots from some real scenarios that we have. So imagine that you have a PagerDuty, so there an alert comes in, and it has some structure. So it has some attributes, which environment it was, etc. PagerDuty, by default, has an SRE agent, which can do the analysis. And if you look at it, based on those attributes, it assumes a ton of things. And I need to admit, it's not bad, given that it doesn't have access to our Git repositories, for example. Is it usable? Absolutely not, because there are so many problems. Just with this particular slide, it doesn't know how do we install, for example, Cerium, where should we really get the error, etc. So it is able to get you some watery generic pieces of advice. I have a nice experience with the PagerDuty folks, and I'm not definitely trying to shame them because they have improved the SRE agent a lot over past months. But for example, in November, they said, no, we don't have any plans currently at that point in time for you to add some context to our agents, which is just terrible. You need to have the context that is specific to you, otherwise you will get something like this, the best. So our approach was to try to mimic what we have locally, because we run Claude Code mostly. We run it in some monorepo style, meaning that we have a lot of Git repositories next to each other, and we just try from the root level, hey, do your investigation, use any of these subfolders that you like. They are, of course, very interconnected, and for some feature, you sometimes need to access 5 of those, so it's not easy. So there are several problems with this. First, you need to invest into some init/init in Claude, and then you need to fit it up with some information, how do you do things. In our case, it's the wiki, and of course, as many of you will have the same problem, if you feed it with some legacy out-of-date information, it will take it as a fact and progress from them, which is typically damaging the reasoning it does, the results it has. So we needed basically to start from scratch. Our wiki is something like medium-sized. We also had a discussion how to connect it properly, because originally all the people say, hey, use some F1 MCP server that there is for it. But we have found out actually that if we let the agent run autonomously, run it on its own, it is typically much better. So our approach currently is that we prefer to have a lot of exports to Markdown in some structured folder. And we basically let the Claude agent roam through those. We also have on each folder and subfolders the init, so there is something like a roster, what can be found in this folder and how to proceed. And typically, we have 30 to 110 tool usages throughout the run, which just explain how the Claude agent works, meaning that it really starts from the root and it tries to read as many information as it feels necessary. This, having it reasoning on its own, was the most effective, as we found, instead of some rack servers and some much more advanced stuff, in fact. Another thing that we were there was a lot of discussion on it, how to approach if we should keep the same session, because in Claude typically you have the same session and you can have multiple chats within the same session, obviously, right? But for the agent and keeping the session somewhere in the Kubernetes cluster non-stop online is not typically a good thing. So first of all, by default at least, our tokens expire in 5 minutes. So if you are not posting another question to the same context, in 5 minutes, you are basically rereading all the tokens, you are spending them again. We were quite afraid to let the agent, with each question it has, basically start a new session. There is, of course, some startup time for the Claude, like, let's say, foundation to run, etc. But the main thing was about the context. And actually, this is quite interesting because we have at least found out that this is not a problem for us. But it also required some tuning, meaning that if you have some conversation, the agent can leave some traces, like, OK, I have checked this, or this is a dead end, or so. And if you add this to your context, then the following rank, even though it is from scratch, it can be highly effective, and you are not keeping many sessions, you are not spending too much tokens as an overhead, etc. So Slack context. This is very interesting because you are running an agent, and our original idea was, hey, there is so much things happening to Slack. We have so many channels. People are discussing in like within the outage what's happening, etc. We would like to feed it like these channels and everything, 7 days ago. Sometimes it works, and here you have a very nice example. So it is able to deduce that in some database, there is not just problem in that single particular database, but there are also on the other databases, other replicas, there are some other problems. So it can tell you, OK, you are not having just problem on this single VM, but let's say outside of the box. It's questionable if we would allow it to, of course, take the data from the MCP and see, OK, there are some alerts firing also on these, how it would work. But this is our approach. Funnily enough, we have found that the agent basically is not reading the context we provided with. It is typically doing some grab sets, and it is trying to narrow the context to as the smallest, let's say, amount as possible and read just what it feels is relevant. So this approach, even though we still use it, is not very effective. And like agent will try, or maybe in some instructions, like we aim it to be effective, so it is not looking around. Looking around means much more context, much more time spent, and in the end, I would say that from our, at least, practice, it's very questionable if you really want it, unless you were explicitly asked, hey, can you look around, what's happening, what alerts do we have, etc. When you will develop AI agents, you will, of course, discuss sometimes if we should have some subsystem as a context, meaning that we would just have instructions how to do it, or if you would like to code. Sometimes it's very hard to decide. And I have problem that seemed obvious for me from the first go, and this is how the agents should output to Slack, because I thought, OK, this is obviously a code problem. I will just have some transposition of the output. So either if the agent will have no formatting at all, possibly, or we will have some easy transposition from, I don't know, like XML to the block kit, which is used on the Slack. This is easy thing to do, right? But when I started to wipe code it, it's not that easy to do. And actually, I found that it's much more effective for you to have instructions, examples, how the agent itself should do it. And then it can do it pretty effectively. Of course, it's spending some tokens on it, but this is very effective. Another problem that we got just outside of it is very funny, basically, because the output gets polluted. And we have discovered that except of the thinking, which we've disabled for the output, there is something like called extended thinking, which is visible as a regular output. So when the agent has started to do the output, first thing, it like internally voiced some opinion it has what it's going to do. This is the first sentence, and then it started to output. When it gets to the context defining, hey, you should output for Slack, that's where the Jameson comes in. So the way we have solved it is that the first instructions is, hey, you need to check the output mode. And this works 99.9% of the time. Not always, but it works quite well. So you will face very different challenges to your coding skills. We would like to get the results from a reasonable time. This is unsolved for us still. I don't know how to solve it properly. Of course, you can choose a different model. If you choose something more thinking like Opus, it will take a longer time, of course. But in general, you cannot force the agent to quit at certain time. You can have it limited by number of steps, and this is the best approach that we currently have. So we are trying to say in the context, hey, you have this amount of time, and please use it wisely. This is how you should use it, like prioritize things that are really important, etc. Sometimes it works, sometimes it does not at all. So this is still unsolved. A lot of MCPs you will encounter, especially in these early stages, they are just some like sparkling on top of the API. And what do I mean by it? If you have MCP-driven architecture, this means that it is very like aligned to natural queries you have, and you query very differently in comparison to the API, right? So in many cases, you will need some translator, let's call it like this, meaning that you are giving instructions. Hey, for these kinds of use cases queries, like find host, you actually need to do netbox get object because, and with these parameters because X, Y, Z. So actually we found out that this worked again pretty well, and for each of those MCP servers, we have some instructions that simplify its approach. It is very easy for the MCPs to expose a lot of data, especially like for us as ops people, we have superadmin everywhere, right? And it's very hard to narrow the data we get from them. So if you would just paste your own token to, for example, PagerDuty in this example, we have, or in return, we get information for all the teams. And given that there is some like non-trivial structure, how can we filter there? It basically resulted in the thing that we needed to have an ID definition. Okay, for our purposes, for this agent, even though you have much wider token, you really need to go just to these ID and filter with these teams, for example, and these conditions. Originally when I started, I thought, okay, Cloud Agent SDK is the same thing like Cloud Code, right? It's just running behind it. And like, this is not true at all, I mean. So you are basically getting some foundation, that is sure, but it has many problems. One that is still unsolved is that the MCPs sometimes fail to start, even though they are network accessible. Some of them run even like in the same namespace, in the same Kubernetes cluster. Like it fails all the time, so we need to retry. Also, the bash is not obvious, right? Because you have something like an allow list, but if you would if you are looking for something fine-grained, you basically need to do this on your own. The title is probably like very stupid at here. There is maybe some new features that might enhance it, but basically our approach at the time is that we are parsing bash ourselves with some library, and we are like trying to guess if this is safe. We are taking just the first command out of possible piping ones, and this is not great. So you need to do a lot of like babysitting yourself in the agent, surprisingly. So I've mentioned a lot of problems, right? And maybe you are not that intrigued to start to work on the agent on your own. But just to give you a hint what can actually work. So first thing, you need to understand how people interact with the agent. And this is, my boss asking it for the first time, what you can't do, and 2 timeouts. Because for some reason, the agent is trying to enumerate all the use cases it cannot do, or I don't know. If you, on the other hand, provide some examples, they are baked in the agents, meaning that you basically, because people will ask, hey, what can you do? They definitely will. So you can help them with some examples. Hey, I'm able to do these kind of things. And by the way, in our context, in our flow, there is some suggestion, hey, let's take 5 examples out of these and just present them. If you would like to look around and you don't understand how Kafka works in this example, so there was a question, can I remove all the Kafka files because I'm running out of disk space? There is a reply. Sorry, I will be skipping a bit through those. You can look up later on because they are maybe like too long. On the right hand, there is a discussion like, hey, can you sum up how our databases in Prague work? And there would be a wonderful answer for it. Also, very interesting, which like use case which we haven't thought of before, is are we vulnerable to some CV? So you basically take the chunk of the definition of the CV and you throw it in. And given that it has a GitOps repositories behind the scenes, it can tell you very likely for this NGINX vulnerability, you don't use the module at all, you are not vulnerable. Perfect. For some first reconnaissance, wonderful, right? Also, given it has Slack history in our scenario, it has history for MCPs for PagerDuty for alerting, etc. It can tell you, is this the first time you are seeing this alert? Were there any historical crashes? How did they look like, etc. It can even do some counting over there. Very interesting fact. Providing links. By the way, this slide probably doesn't look that cool, when I've erased some of the links. Anyway, it can, and one thing that we found out is that the people actually don't want the agent to solve the things, right? But the agent typically is their first contact for some investigation or research. So very useful is that the people from the answer can just click and follow the links and do the investigation or continue investigation themselves or do the fixes themselves. This works very well, and this is really some, let's say, sweet spot of a speed up that the agents can currently offer. Because even though the link, for example, doesn't cover the good parameters, it can still save you a couple of seconds on each click, and this is wonderful. One of the big wins is that we actually have a Victor metrics MCPs connected behind the scenes, and we can again validate. This is, by the way, from the examples file. So you can get information if, for example, the alert is still reasonable, it is still firing. You can get the trends. Are the errors going up and down? And these kind of questions are very easy to ask, and typically you get an easy answer for those without looking at the graphs, or you can even check multiple for some, let's say, more advanced PromQL expressions. Very interesting. It can also run some PromQL expressions or get you the alert definition, so then you know much better the definition of what is actually firing or not. Security, right? A big chapter, also for us. So we have some defense in depth. This is actually some, we are running the agent in the middle. Not all layers are included because we also have some firewalls around it, etc. But basically anything that you would expect is there. So we have some safety prompt, meaning that we have on the system prompt and also on the regular context information like you must not expose secrets, blah, blah, blah. Network policies around the thing, some hardening on the container level, it's inside some Kubernetes cluster that is somehow secured, etc. So sometimes it is working as expected, meaning that when people ask, can you give me the credentials, it is not exposing them. By the way, it even don't have a permission to those, right? Because we don't have a vault MCP or something. And when we, for example, create the context for the agent, we strip all the credentials. Even though they are encrypted, we strip them just to be sure. So it doesn't have that access. This is the first thing. And it behaves very nicely if you ask for them. Wonderful, right? But do we trust it? No, absolutely not. We really need to narrow down all the permissions it has to a bare minimum. And one thing that might be very interesting, on the border of the trusting the agent or not trusting agent is something like this. So imagine that you are really asking an agent to do some mundane work for you. So we have some alert firing that some threshold for an alert for some open file descriptors is probably too low. I know that this has been happening multiple times, and I would like an agent to fix it by increasing the threshold. I cannot do it directly because it does not have GitLab access in our case, but it cannot create a merge request for me, but I can let it create a patch, and then I can just copy, paste the patch, and it's done. And once we are more confident with this, maybe, in the future, we will allow it to have GitLab credentials and do the merge request on its own. Maybe, not sure about this. So this is maybe some middle ground that is also useful, and just explaining that you can progress with these tools really based on some experience of yours, and you really don't need to give them access everywhere. Even though will save me 5 minutes of my time opening repo, opening VS Code, and I don't know what, I can just push it probably with the patch command. The user trust, because we are, as a reminder, we are building a product. So once you lose the user trust, your product is doomed. If you develop, of course, and as I mentioned, there are so many moving parts, so many variables, so many unknown things. Any error that is within the MCP server, as you can see over there for the netbox, that just fails for some reason, or that the people are asking, hey, can you check alerts in Zabbix, which is not connected currently to our server. Any help you are able to give to the people is welcome. So if you, for example, provide information, hey, Zabbix MCP is under security review, and this is why we don't have it, but we will have it soon, come back in 2 weeks. This is much better than, hey, I don't know what Zabbix is. Also, if as you've seen the errors for Slack, for example, previously, this is undermining the user trust, again, unfortunately, quite vividly. How can you get some feedback? Slack reactions actually are perfect. So some of those, bit redirected. there are even some positive ones, you know, at least for the not giving credentials, there were some thumbs up. So it's not always like this, but many times it's always like this, and you just see the frustration. For some reason, you know, people, when they are frustrated, they are much more likely to give you some reaction in comparison that they are just satisfied and like continuing on with their work, right? So let's talk about the real adoption. And this is probably like a very like aligned picture, because, you know, you've seen a lot of really cool use cases it can do. It really is kind of for the investigation, it is nailing things. But people don't use it much. And I think that this is, again, coming back to that people don't understand, even though we currently have some opinion what the AI agent should be or should do, people in general, if you ask them, hey, what the AI agent or SRE agent is for, they don't know, in fact. They are not looking actively to use it. And maybe if they have first 1-2 bad prompts that the agent times out, then it does not have access to MCP server X, or it doesn't have access to backend source code because, you know, we don't allow it there, then they stop using it after the first try. So in order to get you really working with AI agents, you really need to dive in, you really need to take as a product, you need to work with your customers, you really need to do the internal marketing. In our case, for the people to understand what it is, what it can give, what it can get from them, etc. So some takeaways. Of course, no silver bullets, right? Everything that there is just a regular engineering, a mundane work, and it's super boring, right? But you know, maybe there is some silver bullet. So I suggest that instead of doing it like a typical project, maybe you can just wipe code any SRE agent you like. You will become an AI engineer, and you can secure your job, right? Why not? So that's all I had. Thank you. Some questions? Oh, yes, sorry about the blue color. I like it on my laptop, but probably I will need to switch. But no worries, I have another session, so I will, you know, take the feedback and learn from it. Grafana MCP is kind of, I probably shouldn't, you know, publicly say it, but Grafana MCP server doesn't work well. If you know, we also have a proxy from Google that does authentication in front, and we are not allowed to go there directly. So the work I work with